Oh, anybody's home? Hello. Hello, everybody. Oh, hello, Stacy, Kevin, Chandrup. Hello, Chandler. Hello, Onka, Yilu. Anna's here. Raza, Joel, Meet, Isaac, Ali, Antonio, Jonathan. You like my cat? How was the weekend, everybody? Did I tell my our section that Anna's here? Did I tell our section that I got a ping pong table? Anyone? Did I tell our section about my ping pong table? I used to play ping pong in YMCA. No? Yeah, ping pong is good for us. We sit a lot, right? Programming. And we need to kind of, flex our lower back. So flex our lower back. So ping pong's good. Ping pong. Small movement, but twist and turn. I used to play in YMCA, no more YMCA, so I decided to get one. Set it up outside my garage, so every time I take the table out, it's foldable, full size. The setup takes about 7 minutes, and that's it. Ready to go, and you can play about an hour or two. Very good, right? Social distancing at the same time. So try it, everybody. Make sure you find some time to work out. Yeah. You don't retire ping pong. Ping pong retires you. I like that. Okay, Joel and everybody, right? I have a question for you, right? Why can't the bicycle stand by itself? Why can't the bicycle stand by itself? Anybody have an answer? Why can't the bicycle stand by itself? Anybody know why? This was from my daughter Emma. And she asked me the question, so I learned it. Because the bicycle is what? The bicycle is too tired, right? Yeah, so can't stand by itself. The bicycle is too tired. Oh man, it's a lot of fun to have the kids staying home. No, usually I send them to summer camp, but now this summer they just stay home. Yeah, and it's a lot of work for their mom, but I enjoy them running in and out. So, all right, let's get back to business, everybody. Busy weekend. Um, you were busy doing the midterm, but having a midterm for almost a week, right? I hope that we benefit more from taking the time and learning and reviewing everything, right? Did we all get our grade? Did we all get our grade for our exam, everybody? I finished it last night. Okay, everybody did very well. I'm very happy. Our focus is always on learning, right? Everyone got your grade, everybody? Can I have a green dot? Making sure you got your grade. Yes? Oh, some of us did not, huh? Oh, we are not here anymore. Oh, you're checking now? Okay, let's take about 2 minutes checking, please. Um, oh, okay, Sabrina. Okay. I saw your email. All right. Uh, oh, Harry have questions. That's great. That's the whole point, right? The midterm is about knowing we don't know, right? Okay. Everybody got your grade? Please check right now on Island, right? And when you're on Island, I can make other announcement as well. I finished upgrading assignment one's grade for those classmates. I mean, most of us did better on the second one. So I see that we did learn programming methodology, right? Having the same service redo two times, that really helped everybody. So that was wonderful. Hear me, everybody. Thank you, thank you, thank you. My knee's hurting. I just fell off the floor. Yeah. Comcast, guys. Something's wrong with Comcast outside. No, I'm just joking. Thank you. I'm just joking. I fell off the internet, not the floor. Comcast doing something around the block. So luckily that we are back. Okay. Um, yeah, I don't know. I don't know. Yesterday they sent out an email and they said that they increased the bandwidth. I already have the best package, but they are working something around the block. Anyway, let's get back to the business here. Did we all get our grade? Sorry about that. Thank you so much. Can Those are the things we can't control. You know. Um, did we all get our grade, everybody? Did you see any question about the proposal that I have? I hope it makes sense. Because any plan that I make, I want to make sure that we focus on learning and I want to make sure that we learn in the best way, no pressure on the least pressure possible, so that we all can um, benefit from what we're doing. So there's a survey online. Please take your time, and choose plan or A or B, right? And then once I get your answer, and then I'm gonna start releasing assignments. Any questions about my proposal, plan A or and B? Anything not clear to you? Are we all good? Yeah. Please read it and let me know what's going on. Let me explain a little bit about the my plan. So we have assignment three, right? And I mean, back then when we were in person, what I did with assignment three is that we had in class discussion, right? So assignment three has been always having two components. We have a component for in class discussion. That's when we have a group discussion so that we can go through the link back. Uh, no, it's not. We go. If we learn who learned the link back in 220, everybody, I will tell you what assignment three is about. Yeah. So there you go. We should all have learned the link back in 2020, right? Sorry, in 220, our data structure class. Okay. Um, so now what I do is that I try to focus on the code because we already have one route of service. So we learned it from 220 already, and it was in Java. So now I give you the C++ version. Who learned recursion? We learned the topic recursion in 220, right? So we learned that in Java. And actually, recursion C, no Java or C++, any language is the same idea. So what I'm giving you is that usually in when we are in person class, I hand out two packages for us to review, and we get together in our groups, right? And we discuss, and then we give the presentation to the whole class. And then after that, we gonna take on assignment three because assignment three is based on those two. So now, the initial plan was that we just have the lecture, and we can move on to assignment three. But I think it's better for us before having the lecture is that I'm gonna let you choose your own groups. Okay, five people in each group. You can do it across sections, right? So classmate, tic tac toe. Feel free to group together. So five people in each group, and you're gonna meet each other and learn and review the material together. Okay, and try to understand it the first round, and then we also go through it second round in class, and that's going to give you a lot of help with assignment three, and you're going to also get 25 points for getting together and learn. Okay, you can meet at your own space, but I also created a 24-hour right Zoom space, so you can use it directly, or you can just meet each other there and go somewhere you want. So the address is team.dukta.net, right? So that is the 24/7, Zoom hangout space. I'm gonna keep it going throughout the fall and maybe next spring semester as far as we are still online. So I'm teaching 5 classes and I manage 6 other classes for the College of Science and Engineering. So at least 11 classes can meet each other. The classmate from 11 classes they can meet each other and hang out there. And any other student from the CS department are welcome to, have that hangout space. I hope that it's also increased the sense of community, especially for a new student, right? Because what one of the things that I believe that I was a student before, I believe that we miss most from in-person instruction is that you have the opportunity to bump in some classmate, right? To make friends, to ask questions, and now all of that is gone, and most of us feel so lonely studying online. So I want to have a space where we can meet some classmates, when I have office hour, they just go there and park their, Zoom ID, and they said, well, that help them concentrate, help them feel like there's someone there to study with them. That's it. They don't have question. They just want to be there for office hour. So there we go. And of course, I still have. So zoom.tukta.net, right? That is where I host, our class meetings and office hour, and team.dukta.net is the open space, just like our computer lab, okay, or the social hall anywhere that you can use student union. All right, okay. Since the internet has a little bit of a problem, so let's end the news part of our meeting today, and let's get to the midterm exam, okay. Who want to go through all the midterm exams questions carefully? Let's go through all the questions and make sure we take note, because some of the question going to appear again in our final exam, right? Everybody's good here? Are we all ready for this? Yeah. Who's ready for this? Am I still here, or I fell through the floor again? Yeah, ready? Okay, let's take our midterm out, everybody, and then we do it. Let's take our midterm out and then we do it. Midterm. Harry has question, right, Harry? Okay. All right. So on Island, I post a message this morning. Right. I finished grading our midterm exam. Good work to everyone. I'm very happy that we created another learning opportunity. We benefited from having the exam as a take-home exam, and from doing it thoroughly. Right. So the key word here is that we had a lot of time to do it really thoroughly. I mean, the question got me thinking hard. Oh, that's good. That's good. That's good. You know, it's good um, to have things that make you think. That's the best, right? Um, and I remember reading a joke. Right? It's great to have new stuff, but it's dangerous to have a brand new brain. Right? You know, we got to use it. It's most dangerous to have a brand new brain. uh, I, it's always scary to learn new things. Oh no, Jay, I don't agree with you. No, no. I mean, we are young people. We are in tech. When you see new things, you jump into it. You love it. It's a chance for you to explore. Cannot be scared to cannot be scared to learn new things. Hmm. So there's a research from Harvard, right? If you want to stay healthy and stay young, yeah, you have to always look to forward to learn new thing and meet new people. Everybody, okay. What makes life happy? To have a happy life is not about the money. It's not about the position. We need it. We need the money. But what makes you happy is to have good people around you. That's it. After all, so this research was done on 37,000 people, right? Across how many years? I forgot. I think 11 or 13 years for Harvard to conclude that, what makes our life happy in the end, right, is about the good people we have around us. Okay, good family and good friends, and that's it. And if you want to keep, ourselves young and healthy, always learn new things, and look forward to meet new people. All right. Okay. I know that Jay's joking all the time. He went to office hour and we had a good talk. Um, so right here, right, on Zoom class meeting, I post the answer to all the midterm exam, everybody, right? So see what I got in here. I have the midterm exam in PDF format. I have the midterm exam in Word format for you. I always have some good readings for you, right? So good reads. So please, when you have time, please read that. And I have all the answers and code of the questions in both C++, CPP form, right, and PDF form. So you can open, on almost any devices, right? I also, most importantly, is the README file. In the README file, from A to A1 to A7, B1 and B2, right? I gave you the exact lines in the exact package where you can find the answers for our midterm exam. Everybody know where to find the documents, everybody? Everybody, do we all know how to find this, right? I post it on iLearn, okay? Again, I post a link on iLearn and it's also on our file manager. So we can go there and see all the answer, including the original exam in both, code form and PDF form first. Everybody's good. So now let's go through the exam together. Okay, please give me all the questions, everybody. This is your chance, right? This is your chance to ask me all the questions you may have. So let's go by the order, okay? Is that okay with everybody? Just go from one to the end, okay? All right. How is a pointer different from a reference variable? Everybody, can each of us give me one sentence, right? Type as fast as you can. Okay. How is a pointer different from a reference, please? This is old material, right? We should all know this. Everybody, come on, let's review together. Give me one sentence. There are so many things to say about, pointers and reference. And later, I'm going to give you some advanced knowledge about pointer and references when we are ready, right? When we are ready. There's one more piece that we should all learn about pointer and reference. It's very advanced, but we need to make sure we get this midterm out of the way and understand the knowledge before I can explain that to you. So okay, let's see what we got here. Let's see here. So we have K pointers have their own addresses, right? References is another name of one variable, right? Existing. A reference variable has the same address as the variable, while the pointer have their own distinct addresses. Very good, right? So pointer point as the value, reference address. Very good. Reference variable share the address that it refers to. Very good, right? So we see that our classmate, right, and all of us have been doing great here. So if I were you, I would screenshot all the answer. Those are great, right? Okay, so again, let me give you a quick, right. Everything that our classmates, said was correct. Right, I just checked already. So now let me give you a comparisons in picture, right, and you can add, more to it. So now, first of all, we talk about pointers, right? If we talk about pointers, and on the right side we talk about reference, right? We've been going through this many times in this class. So pointer means, we have an object, right? For example, at Z. Everybody's good, right? And then we can have pointer A, B, C, D, and E, as many as we want. And they point to the object, right? So make sure that when we point, the line has an arrow there, right? So pointing to the object. Everyone's good here? So now, if we also have an object on the right side, and we have A, B, C, D, E as the references, Okay, so the difference that our most of our classmates have said, in the text is that a a got to be at its own location, right? This object we can name it z as its own memory address, a as its own, b as at its own, right? C as its own, and d at its own, and e as well. Everyone's good here, all right? So what is the value? What is the value that A, B, C, D, and E gonna hold in their memory address? Everybody, in their memory location. What value do they hold? All of them hold the address of Z. Are we all good here? Right? All of them hold the address of Z. And Z, let's also review more than that's the exam. Okay, let's do a very thorough one, so we learn more than that. So Z is a label, right? The name of the variable, right? And this is a memory address. This is a memory address. So that's the third thing. And it also has its own value. Does it make sense now, everybody? Right? So in Z, if Z is an integer, for example, right? It can store a value of 5, for example, right, in there. So that is the second dimensions of a variable. Everyone's good here? Are we all good? Yeah. So now on the right side, what is the address of A, B, C, D, and E? Everybody, what is the address of A, B, C, D, and E? What's the address of A, B, C, D, and E? Do they share all the same address? That's right. They at the same address, right? They have the same. They are at the same address as Z. They are at the same address. What's their value, please? If they have a value, what's their value, please? So if we have Z here, let's say Z here equal to 5, right? So what is the value that A, B, C, D, and E has? Also 5, right? Okay. All right. This is awesome, right? So now so what kind of structure we use to manage references, everybody? What's the name of that table? What's the name of that table that I mentioned when we learn? Anybody? You wanna see this table a lot more when you get to graduate program. Okay, what's the name of that table that we are using to store all those references? What's the name of that table, everybody? When we say everything in that table, dinner table, yeah, pretty close. Which one? Yeah, lookup table. Everybody is good. That's what they call. So the keyword lookup table is used in many contexts, and I'm sure that you're gonna learn. Doesn't matter what class you're gonna take later. Okay, but the idea here is that in you look up, the actual variable that all of those references or any value in another column. So this is one column, and this is we can call it the reference column, right? And they all reference the same item. So they call that the lookup table, right? If you take networking, if you take web development, anything, they all have that concept. So let's try another one more here, right? Um, when we declare a pointer, right? Do we have to initialize it, everybody? Can we have a pointer? We don't have to, right? Very good. When we declare a reference, do we have to initialize it? Yes. All right. So that's another point. So pointer, we don't have to initialize, but references we have to initialize. Okay. Pointers, right? If we have A currently pointing to Z, can we reset A to point to something else? Can we? Yes, right? Okay. Can we make this A on the right side to reference something else? Can we? No. Are we all good? Right? Okay. The last question, and probably the most advanced question when it comes to pointer and references. Um, are references and constant pointers are the same? If you go to interview, are, are references and constant pointers are the same? References versus constant pointers. Are they the same or not? Are they the same? Yes or no? Oh, why quiet? That's right. So look, Mitchell's right, right? No, because even constant pointer has its own address, right? Constant pointer just mean, well, you are a pointer, you are pointer A, you are pointing at Z, and you cannot change to point to anything else. You're stuck, and that's it. Does it make sense now, everybody? Right? You're stuck. You're done. And that is the, you know, I think the question that people like to ask a lot when you come to, comparisons between pointer and references in interview. So please remember that, right? And they always go back from there. Okay. Harry has a question. Go ahead, please.
Yes. So we studied like in some cases, R value references, they have their own address. And would it be okay to say are R value references same as constant pointers?
No. What's the difference between R value references and what's your question again? Come again, Harry. Sorry. R value
We said
references
like
and what?
the main difference between references and pointers is like references, they don't have their own address. But in some cases, like in R value references, they do have their own address, right?
Oh yes, absolutely,
Um,
absolutely.
okay, I'm confused.
But remember, this is a question in the end of package number 5, right?
Yeah, yeah.
So our value has memory address, right, and
Yep.
size, right? So what
Mhm.
is the memory address and what is the size of an R value reference?
Don't they have their own address?
No, they have the. So we have to be careful with this, everybody. When we talk about a reference, right? So let's compare between. This is not in this question, but it's good that Harry asked. So if we have an L value reference, right? L value reference. If we have an L value reference, we are saying this. We are having an existing object, okay? And let's call this, this is R1. And this is, oh, I already gave it a name already. So if we call that, L value reference, right? So if we have an object at Z and name Z currently existing, and we make an L value reference, then this L value reference gonna be, also as Z, right? And as have the same content as Z. So now if we have an R value, and an R value, is a temporary value. Everybody's good now, and it's soon to be gone. This is most important sentence here. So everybody ready? It's soon to be gone. That means there's nothing left, right? That's why when we say if we have this R value reference, is going to adopt that R value. In the next package, when we go to C++ class, we will understand very much better. So this R value now, they in programming they call that binding. So binding or attaching, right? That's mean you are giving this value, a name, an address, you know, and a value and a reference for the first tab. That's why our value reference, has its own memory address and value, and it adopt, this value 340 to be the value. Are we all good? Or you can call it an object if that make it easier for you. So this object and reference now sharing the, memory address of the reference. Everybody's good now? Basically it's almost the same. It's just the way that you word it to make it, to show the interviewers that you understand how the process work. Harry, go ahead. You still have questions?
No, I think I got the answer.
Was that
Um,
clear? It's just about the order of what comes into existence first and what is going away, and that's all matter. Are we all good now?
So you're saying the difference is that the R value reference is would be temporary, even though it has its like same address and points to a different value, even though it has its own
No,
address, kind of like a
no, no,
pointer.
no. The R value is temporary.
Okay.
340 is an R value and L value or an L value.
It's R value. Yeah.
There you go. So
Okay.
R mean it's gonna be gone, right?
Right.
So now if we give it a name for the first time, right? Uh, uh, R value reference, and that is a name. So if this thing is gone, what can we use from it? Nothing, right? Are we all good?
Yeah.
Yeah. So we got to use the address of this, and this is a Z. Everybody's good now. So that's why we keep repeating again and again. L value means you are referencing that something existing. And then that, if it is existing, then you got to share the same address and value of it. But R value is a totally a different story. R value means, you are adopting rather than you are adopting some, temporary value, the first half. So you cannot attach yourself to it. You got to say, well, it's gonna go with me. When we come to the big five of C++ class, you will see this point much clearer. I know that some at this point, for some of us, it still sounds like the same, and that is okay. Don't worry about it. Okay. More question, Harry?
Yeah. So we can say that R value can have their own address, right?
It our
Oh,
value do have.
references can have their own address in case of R values.
Yes. Yes.
Oh, all right, thanks.
Yeah. When we get past C++ classes, I'm gonna open a page in the international standard of C++. And on that page, right, there's a lot of argument about that page, and I'm going to show you, which one is the real explanation for the architectures of reference and pointer. For now, right, for classmates who are curious, right, I want you to start thinking about this. I want you to start thinking about this, and when we get to that point, you will be very satisfied. Remember that we in package number 5, right? We're talking about the main, and then we're talking about the swap. Everybody's good here. We're talking about the main, and we talk about the swap, right? So at some point we say if we have x and y, and then if we have n1 over here and n2 over here, and remember we said, oh well, n1 is a reference of x and n2 is a reference of y. When we say that we pass by reference, right? But we did not ask me a question that I've been waiting for. That's why, and I would not explain until we ask because we were not ready to see that. That's why I want to wait until you start to see the conflict and you're gonna ask that question, and that's when the best time for me to give you the explanation. But since Harry asked the question, I want us to start thinking, and then in several meetings, I'm gonna explain to you. The problem here is this: if x is as address x, right, and n1 is referencing x, that means n1 has to be also have address of x. Does it make sense now, everybody? My question here is that if n1 referencing x, it is impossible to have two same address x in a two different scopes, in the two different programming stacks. Do we see the problem here? And we finished the whole package number 5, but nobody asked that question. Does it make sense to us, everybody? Does it make sense here? When in a two different activation records, right? Two different activation records on the runtime stack, and we have the same address. It does not make sense at all. It does not. And in the international standard organization's book for C++, they hide this information. However, in the programmer communities, we have the explanation for this, and I will give it to you. Okay? All right, I will give it to you when we get there. So keep thinking about this, please. And to really go to an advanced C++ interview, they will ask you about this. They will ask you about this. And if you can point out to them exactly on what page in the ISO C++, they hide the information. Wow. You will impress them a lot. All right. Would this statement here cause an error and why, everybody? Would this statement here cause an error and why? Yes, yes, and the reason is what? We talk about this on top. That's right. Thank you, Alfonso. Right? We cannot reassign reference, also as William and Mitchell said. So we already have, this is the L value reference referencing some existing object, right? We cannot reassign it. We cannot reassign it to reference something else. Doesn't matter if it's, year next or year previous or anything. Everybody's good here? Everyone understand this explanation? Yes, yes. Yeah. Okay. All right. So next, any other questions about pointer and reference, please? Thank you, Harris. Again, very good questions, right? Very good questions. And Harry actually took us to the discussion that we're gonna have in two meetings about reference again. Okay. Dangling or stale pointer. Can we please explain this, everybody? Dangling and stale pointer. What package was this? What package was this? Always refer to the readme file, right? So I prepare a readme file for us so that, so if you go to the answer, right? For example, A2, and we say in package number 3, line number 284. Okay, let us see if my note is correct for you. Okay, so package number 3, and what line number again? I forgot. Package number 3, what line number? Package number 3, line number 284. Package number 3, package number 3. There we go. 284. 284. There we go. Right? 284 is when we talk about stale and dangling pointer. Everyone's good here, right? And if you look at that page, you found your answer. Are we all good? Right? So now let's talk about stale and dangling pointer. What the question is. What is a dangling or stale pointer? Please give a code example. So here's a code example, right? We are saying this on line number 275. We are creating a pointer to point at an object, and we will create it, using new, right? So let me ask more questions so that we can learn from here. Where do we store the object that we create with the new keyword, everybody? Where do we store the object that we created? Area 3, free store, right? Free store. Where do we store the pointer, everybody, that pointing to the new object? Where do we store the pointer? In area 2, runtime stack, right? Very good. Activation record. So we have from area 2 that we are pointing to an object in area 3. We use keyword new to create. Okay. And then on line number 285, what did we do, everybody? When we say delete PST1, are we deleting the pointer, or we are deleting the object that we point to? We are deleting the object, right? We are deleting the pointee. Very good. So at this point here, we are deleting the pointee. Are we all good? So if we delete the pointee, then the problem is that this pointer right here is still dangling, and it's still pointing at the object. Everybody's good? And let me give you the pictures again. So if you need to explain, right, to anybody what is a dangling pointer, you said this. I have an object, and I have a pointer pointing to an object. And then I pop that object. That means that object is gone. And this pointer is still now pointing at that memory location. And that is a dangling pointer. And if you write the code, you said, well, I'm on the runtime stack, right? And I'm pointing to the free store area. And I took out the object because of, I created using new, and then I use delete to delete the object. It is now gone. It is now gone. It is now all gone, right? Because of delete. So now it's dangling because it's still pointing to an address, where the object used to be, right? That is what it means by dangling. It's still pointing to that. How do we deallocate an object properly, everybody? One more step that we need to do is what? One more step we need to do is to fix to set the pointer to no. Very good, Mitchell, right? We set the pointer to no. Okay. Everybody's good. Oh, sorry, to no, not to an object. Well, actually, you can also set it to another object. Yeah. Sometimes when we have a pointer that we don't use anymore, right? And if we want to point it to a different object, that's a good way to do it too. As far as it's pointing at something existing, not deleted, that means it's not dangling anymore. Okay. All right. This is very good. Um, Please, give instruction how to properly deallocate an object allocated on free store. Please use a code example to demonstrate. Right here, the whole code is given here. I even, wrote a brand new example for us. Line number 288 to 290, right? So let me explain this another time for all the classmates, okay? We create a pointer from area 2 and we have it point to an object we create using new in area 3, right? And then we said, I'm going to delete, right? I'm delete the pointee that pointer 2 is pointing to. That means we are deleting 3, right? 3 is gone. So now at this point on line number 289, that's when we have dangling pointer. But now here is when we say, okay, if it's dangling pointer, it's a dangling string. I pull it back and have it, point to no pointer. And that's what it means by proper deallocation. Everybody's good here? Any other question for A2? Are we all clear about A2? Is it hard to keep track of each pointer to prevent memory leak? And if you have a big program, it is super hard. It has been always a reason why people stay away from C++, Jay. But the next package we're gonna learn smart pointers, okay, and that is the solution for us. Because when we're talking about um, the alternative is smart pointer, but smart pointer we need to know how to use it. Otherwise, we're gonna create more problem. Okay. Uh, um, um, in a game, right? We are not talking like Jay is saying here. Jay probably program game for web, right? We're not talking about one pointer, everybody. We're talking about thousands of pointer. Yeah. And we're not going to manually go after each of them and do new and delete. That's the problem. We cannot go after each of them and do new and delete. We have to set up a kind of, set and forget mechanism to manage it. All right. My partner loves smart pointer. He say it's always make things easier. Yes, that's right, Kevin. If we know how to use it, properly. Even if the pointy object is not stored in the free store, would the delete keyword have the same effect? Even if the delete object is not stored in the same, we can only Joel, very good question, right? Because new can only end up in area 3. Okay, so only delete object in area 3. So there's no such a scenarios when delete gonna delete something, not in area 3. Are you good? That's a very good question, William. If we do not plan on using the pointer again, would we just delete the pointer rather than set it to no before deleting? There's no way to delete a pointer, William. There's no way to delete a pointer. There's no way to delete a pointer. Yeah. Um, so if we have a pointer, yeah, yeah. No, no, you're not confused. Um, you're not confused. We can't delete a pointer. A pointer may go out of scope. That's what it is. Remember, everybody, the keyword delete is only used for a new, right? We cannot create a pointer use a keyword new. New is only for object. So we cannot delete a pointer. We can reset a pointer. And if a pointer is in the scope, by the way, everybody, All the questions that our classmates are asking are excellent questions. They have those questions because they have been doing the midterm very thoroughly. I can see that. So this is great opportunity to learn here, right? So in this case, William and everybody, if we have a pointer that in the scope of a function, and if we pop this activation record, right? So this is when it goes out of scope. That's it. Whenever we put a delete to a pointer, it only deletes the pointee. Yeah, we cannot delete a pointer. Okay, so last line here. So the pointer always keep its location memory, and delete is especially for deleting the object that the pointer is point to, using new, right? Mitchell. Again, everybody, I know this is also advanced, right? New and delete is a one and one relationship. New and delete is a one and one relationship. If we have new and we don't delete, right? We have a memory leak. Okay, we have a memory leak. If we don't have new and we try to delete something that we did not create, we have a memory crash. Are we all good? And that's why, and new, right? And the only way to get to new is through a pointer. You see the relationship now. So that's why having a dangling pointer is so dangerous, because dangling pointer is gonna lead to deleting something, that or that forgetting to delete something that we create, or we delete something that's already gone. We call that the double delete, the problem. And the same on package number 3 here that we discussed last time. Double delete right here, right? Are we all good? All right. If it goes out of scope, why do we need to set it to no pointer? Okay, that's a good question, right? Totally a valid question. If we're gonna go to the scope, why do we need to put it to no pointer, right? So what if within the so here we go. If this is activation records that Harry, right? And and this is a free store. This is a runtime. If we have a pointer pointing here, right? And let's just say here. So now this object already deleted. So this is the duration of this activation record. Are we all good? What if during that time you want to reuse this memory, and this dangling pointer is holding on to that memory address? Is that efficient memory management? No, right? So the moment you are not using it, you have to put it back to no right away and free the memory, Harry, right? And we always have to take a step back, right? The memory free store here is not only used by this one program, it's used by many programs at the same time on the server. And if we have a memory location that we cannot use, it's a waste of memory. And this is a case when we say we can allocate memory randomly. What if we organize memory in a linear fashion? If we have a problem with one memory slot, right, we cannot advance to the next one, then we have a bottleneck, and that even worse. Does that make sense now, Harry? Does it make sense? Right? Okay. All right. Very good question. We spent a lot of time here, and eventually it's gonna make it easier for the next packages, everybody. All right. So I don't mind spending more time explaining to you stuff. Okay. So next question. Any other question on that? Any other question on that A2? Right. So next one is A3. All right, A3. A3, midterm exam and tick section. Okay, A3, A3, A3. Let's go to A3. Okay, A3, balance current. All right, where do we store balance current, everybody? Where do we store balance current or current balance? In the 4B. Very good, Alfonso. Um, why is it 4B, please? Why is it 4B? Why is it 4B? It started from 26, right? And then it connected with 31. So it is 4B because of what, everybody? because of this one keyword that is so important that, and we learned this already. We learned this, in the last class. That's right, static. That's right. If it's a static variable in a class, we have to initialize it at outside of the scope of the class. Remember, everyone, right? The scope of the class here is on line number 11 to line number 29. If it's static, we have to declare it right away, and we have to declare and initialize it, right? We have to initialize it right away, and it has to be outside of the scope of the class. And that is on line number 31. Okay? And on line number 31, it was, initialized to this value. So it's for B. Any other questions here? We're going to have more practice on memory management. So don't worry, everybody. There's a lot of practice coming next. CC2. The next question is on CC2. Where is CC2? On line number 35. Where do we store CC2, everybody? CC2. CC2 gonna be in 4B, right? CC2 gonna be in 4B. Everybody's good, right? 4B. And why is it in why is it in 4B, please? It is when it's difficult, right? When it's difficult, we always ask the question of what is it? Everyone's good here, right? Okay. When it's difficult, we always ask the question of what is it? And what is it? Yeah. Oh, that's a good question by Kevin on the top up there, right? Kevin, um, Kevin is asking, 4B over here. This is very interesting. So Kevin said, wait, right? It was initialized, but it's initialized to 0. It should be in 4A. That's a great argument. However, there's a little tweet here. When it's automatically initialized to 0, Kevin, right? Like the example we did in package 7. So when it's automatically, remember in that example on the top that it wasn't initialized by us, right, manually. On line number on the top here, we actually manually initialize it to 9. So it has to be in 4B. Are we good, Kevin? Yeah. That's very good. I like it. I like how you pay attention to detail. Very good. Very, very good. I like it. On line number 35, right? When it's difficult, we want to ask the question of what it is, everybody. And in this case here, it's a pointer, right? And it is static, right? And it is initialized. So it is the reason to ask the question of what it is, because we don't want to be confused between the pointer and the object that is pointing to, right? The object that is pointing to is in the new. I saw this in the midterm exam. Some classmates said, well, CC2 was created using new, so it is in the area 3. No. CC2 was in area 4. And it's a pointer, everybody. It's a pointer to an object that was created in area 3. It's a pointer to an object that was created in free store. Are we all good? Right? So CC2 was in 4B. And the reason for it to be in 4 is because it's static. The reason for it to be in 4B because it's initialized. The object that is pointing to is stored in area. What area, everybody? Area 3, right? New, so area 3. Are we all clear now? Yeah? My ears are blocked today, so I can't even hear what I'm saying.
So you're saying that like the new credit card Platinum is in area 3, but the static credit card Pointer that would be area 4. And so
That's right.
since it's just pointing to that object, and then we have this whole like static thing going on, we should just assume that it's in 4B.
So that is correct. Let me ask
I mean,
William
that's
here.
a vague way of saying it, but yeah.
No, no. Let me ask William here so that we can help our classmate review this another time. Why is the object in area 3 on
Because
line number 35? Why is the object in area 3?
because
Because
it's
it
the new
was
keyword. Yeah.
it was created using new, right?
Mhm.
Okay, the new operator. And then CC2 is what? Is that an object or a pointer?
The pointer.
It is a pointer to an object. And on the left side, we see that this pointer was a static or not. It
Yeah.
was static, right? So now for B or for A, it all depends on whether it was initialized or not. And it was initialized, so it has to be in area for
B.
B.
Okay.
Okay.
Cool.
Does it make sense now?
Yeah.
So, okay, I give one more detail that may help some of our classmates. Okay, let me erase everything here. If you are still confused about this concept, which is okay, you want to pay attention to this one thing, everybody. The star, right? If we create an object, right? If we create an object student, right? Student 1 equal to student, for example. Okay. And this is going to be what? Student 1 here is a what? Everybody, is it a pointer or a reference? I'm comparing student 1 and CC2 here. What's the difference? Remember, we learned this in package package number 6, right? It is a reference. Are we all good? So over here, it is a reference. It is in area 2, and it is the same address and the same area as the object, right? This is an object. This is also in area 2. And they are at the same address, right? They are at the same address. And then for this one here, because we see the keyword new and so we see the star, right? So what we see here, CC2 is not a reference, it's a pointer. It's a pointer. It is in area 2. It's pointing to an object created using new in area 3, right? So it's pointing like this. So of course, this one has its own, address A, and the object is address B. Everybody's good here? Everyone's good? Do you want me to draw a picture to show you what's going on? Yeah. I can also draw a picture to show you what's going on here, right? So now let me make it a big picture so you can see better. So here we go. If we have, the pointer, right? CC2, right? In area 2, and it's pointing to an object in area 3 that was created using keyword new. So that is a picture. Okay. But if we have a student object, the student object was created here, everybody, because the student 1 object was not created using a new keyword. So it's going to be right there on the same runtime stack, right? Area 2 and area 3. Everyone's good? Any question here, everybody? Are we all good, right? Did I give you package number 7? I did, right? Last time we studied package number 7. All right. Next question, please. Next question is CC4 the object. Okay, CC4 the object. Where's CC4 the object, everybody? Where's CC4? Where did we store CC4? Oh, CC3, huh? Did we do CC3? CC3 the object. Okay, we do CC3 first. Okay, where's CC3 the object, everyone? CC3 the object. It's in area what? CC3, right? So first of all, we have to ask the question of what is CC3? CC3 is a what? It's a L value what? Reference, right? Reference. And now we said, well, it's referencing some object that returned from own credit card function, right? Then own credit card functions is on line number 33. And in that function, we did a bunch of things and then we returned this. Okay. So now we said, well, if it returns right here and then it get, reference right here. So now we say, what did it return? When it returned the dereference of CC2, it's returning this, CC2 object, right? And we just talked about CC2 object. In what area is it? It's area 3. We just learned about it. Any questions here, everybody? Any question? It's referencing an object in area 3, right? Are we all good? Okay. So now CC4, right? CC4. CC4 the object. So CC4 the object. So where is it stored, everybody? CC4 the object. CC4 the object. Where is it stored? Area. Why is it area 2, Alfonso? Why is that area 2? Because of what? Because of what? Line number 45. Well, constructor, every object, user-defined object is created using the constructor, right? Was it created using new or not? That's what we are talking about here. Was it created using new? No. That's it. And CC4 is a reference, and that reference is within the main on the runtime stack, area 2, right? So they got to have the same address. They are right next to each other on the runtime stack. Everybody's good now? So it is area 2. Okay? All right. So the next one is the output of the program. That was pretty easy, right? So any question about why the output of the program, everyone? So if we understand, all those. So first of all, let me explain then. If we look for the output, right, we have to always first we want to look for the C out, right? Everybody, we look for the C out. Just a side question: CC4 is an R value reference. Yes, it is. CC4 is R value reference. Yes, it is. So, and this is a clear example for you, Harry, right? We have a reference that adopt an object that was created on the right side, right? The object on the right side did not have any, name at all. It's an anonymous one. Does it being in the main have anything to do with it being area 2? Of course. Where's the main, William? Where is the main? Where is the main? Runtime. Runtime is what area? What area is the runtime? Area 2, right? On the chart, main say it area 1. No, 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 no. The parameters that we pass in the main are from area 1, not the main itself. Package 7, yeah. We will get to package 7. Yeah, be careful. That's okay. We're going to learn that. We will go through the initializer list, Joel, okay? All right. So for the output, everybody, let me make sure I don't lose the class here. On line number 43, 47, 50, and 53, right? So now, with the practice, we see that we can identify where exactly the object is, right? And if we have the object and we follow, right? For example, CC3 here, right? We understand that we create the object using, the using the function on credit card, right? Coming from here, and then we call from here, then we know exactly that, why we get the certain output, okay? And same as here, get info. So notice here that because it is a pointer, right? So we use the arrow in order to get to the function, member function. And when it's an object or it's a reference, then we use a dot, in order to go to the get info, right? So get info. Any question about the output of the program here, everybody? Any question about the output of the program here? No, there's no arrow at all. There's no arrow. Here the output here. How many of us put the code in the IDE and run it to get the answer for part B, everybody? Oh, you got an arrow? You got an arrow because probably on the top, and or when you copy, did you include, the library? Did you include the namespace, everything? Right? Can you explain the fourth line? What is the fourth line, Stacy? Tesla Silver? Is that what you are talking about? Tesla Silver, this one? Okay. So now let's trace it together, everybody. Let's trace it together. Okay. Um, so first of all, right? Tesla Silver, right? Tesla Silver. So like CR4, we looking for the object number 4, right? CC4. So where did we create CC4, everybody? We create CC4 on line number 45, right? Right? And CC4 is on line number 45. When we see this, what are we calling, everybody? What are we calling? When we say create credit card CC3, credit card CC3, what we are calling here? Credit card CC3. What we are calling? String type, string type. Credit card CC4 equal to credit card CC3. What we are calling? We are calling the copy constructor, right? Did we? Yeah. So CC4 is what? Is CC3, right? And then we set the company to Tesla. We test the company to Tesla, right? So now, and then here we just output. So we did not change CC4. It did not change CC4. It did not change CC4. It did not change CC4. So we are passing in Tesla, right? And then when we call get info, what does get info print? Get info gonna print the company name and then the type of the credit card. So the company name is, Tesla, and the type of credit card is got to be silver, right? So where did the type we get from? Where did the type we get from? We get from type of C, right? C3, and C3 of the type silver because C3 C3 was silver because of this. On line number 34, right? We have C1 is of type silver, and then we create C2, and then C2 is of the type platinum. But then on line 37, we say that we're gonna override content of C2 using C1. So C2 is now silver again. Does it make sense, Stacy and everybody? Right? So it was silver, right? It was silver here, and then we create C2, right? It's platinum, and then now we say it is silver again. That's why when we return back to the main, we return back to the main here, right? On line number 45, it is CC3. That's mean it gets silver, and then Tesla. So Tesla and silver. That's what line number 4 should be, isn't it? Yeah, Tesla and silver. Does it make sense here, Stacy? Why doesn't 52 change CC4 to Disney? Because that line was not changing C4. It was changing C3, right? It is C3. Does it make sense now? 52 did not work with C4. Does it make sense, everybody? Oh, Kevin say, oh. C4 C4 was but 46, Stacy. So you say here, right? C4 equal to C3, right? And then 46, that's when C4's company is Tesla. Does it make sense now? That's right. That's right. Sackham is explaining very well. It doesn't reference it. It's only copy it and then it change on line number. Doesn't matter if it's fair reference or copy actually. On line number 46, that's when we set the company equal to Tesla. Does this make sense now, Stacy and everybody? Everybody? Yeah. Okay. Can I have confirmation that we all? You're welcome. So we have got to pay attention to the detail, everyone. Are we all good here? Yeah. Can I have some about 5 confirmation before we move on to the next one? All right. So I plan to move on with more material, but it's okay. Let me go through this thoroughly for everybody. So I've been explaining it, very carefully here for us. Okay. All right. Good questions. Very good questions. So now let's continue with our midterm exam A4, right? A4. Oh, well, we've been talking about A4 already. So you see that the exam actually repeat itself a lot. And I did that on purpose because I want to help you recall, the knowledge. And there's always some warm-up question like A1 and A2. You're welcome, Kevin. Thank you for your question. Thank you, everybody, for asking very good question, actually. Um, our section is actually a little bit behind the other two, but I don't mind at all. And for the fact that many classmates from TIC and TOE actually go to this section too. So, I always put learning first, not the exam, not the assignment. So make sure we do something well, learn well. Please explain each parameter passing method, when to use it, and a code function prototype, for example, right? Pass by L value reference and pass by R value reference. Are we all good? So we talk about this a lot. Where can we find, all the information, all the example for the function related to L reference and R reference? Everybody, what package, please? What package, please? Right? What package that we have to do with L and R value a lot? Everybody, what package for A4? What package we go to? What package, please? Right? I give the answer here. Right? Package number 5, everyone. Okay. If we go to package number 5, we have so many examples of this, right? I can go to package number 5 now. How about that? Right? So let me explain everything again just in case it helps somebody. Package number 5. Package number 5. Package number 5. Here we go. Package number 5 for tick section. There we go. So all the L and R, right? It was all over here, and we talk a lot about all those L and R. Wow, look at this. Oof. L value reference. Okay, and here we go. So if we want one example, right? Let me clean this for you. That really solid for this. You can use any. I give you so many example, but there we go. So if we say here, explains pass by L value reference. There we go. On line number 397, right? L value reference, 1 or 2 ampersands, everybody, for L value reference. Is that 1 or 2 ampersand when it comes to L? Very good. Wow, look at our classmates, so fast. 402, when it's R value, we go by, right? We go by R value reference, okay? By the way, we have the same review in TAC and TOE. Any classmate need even more explanation, welcome. Okay, welcome. Pass by L reference and pass by R reference. And here in this case, if we don't want to change the content, we can always put a constant in here. In the next package, everybody, I'm going to show you how we take advantage, not take advantage, we make the best out of an R value when we don't use a keyword constant. Let me explain right now before we get there. So the beauty about an R value object is this, that usually, right, usually when we create an object, and the goal of modern C++ is that if we create an object and we put it as an address Z, for example, as much as possible, we want to keep it constant right there. We don't want to move it around. We don't want to copy. We don't want to, delete, and recreate. We want to keep it at the same place. However, for an R value object, right, we know that it's soon to be destroyed. It's going to be gone. So the opposite is true. It's true. Whenever we have an R value object, if we can change something, okay, just to get something else done, we want to change it. So in that case, we don't want to keep it constant. Everyone's good here? Everyone's good here, right? So last time we talked about an R object that we don't have, any connection to it, so we cannot change it. So in the next topic, we're going to learn how to use an R object for a split second and save the memory. Okay. I know that some of our classmates start to have questions right now. Make sure we keep thinking to that direction. It's going to be very good for the next package. Okay. So now let me answer the next question here. When to use it? Oh, this is an easy answer. So when should we use L value and when we should use R value, everybody? We spent a lot of time on this last time. When should we use L value and when should we use R value? When we what? We use L value when what? L value reference when what? When the object is non-temporary, right? Everybody's good? That's one example, right? We use an R value object is what? When the object is an R value or is an anonymous object or is an object that's soon to be destroyed. That's it. Very simple. Everyone's good here? That was A4. A5, right? Any question for A5, please? Any question for A5? I actually got some classmate, exchanging email with me on the weekend about A5. So I think absolutely I want to explain A5 as well. We've been explaining everything anyway. So A5, right? Any question for A5 here? Let's look at A5 together. Okay. This is the question. This is the answer. A5 PDF for you. Okay, so A5. The first question is what? Please quote a constant pointer. All right, so that's the first thing. Please quote a constant pointer which points to a pointer. Everyone's good now, right? How do we write a constant pointer, everybody? Can somebody give me a quick answer? How do we write a constant pointer in terms of syntax? How do we write a constant pointer? What is the rule? Something that we learned from package number 3, right? 2 pages before the last page. We have to keep the keyword const right next to the pointer. Everybody's good now, right? If the keyword const is on the left side of those, of the star, it means if we have const on the left side, it means what, everybody? We learned this. Remember the example? We learned constant integer, constant pointer point to constant integer, right? So if we have constant on the left here, it is a type of the pointee. That's right, Joel. If we put constant on the left, it is a type of the pointee. If we put constant here, it means the pointee is being a constant integer. But if we want to say that the pointer itself is a constant, then right next to the label, the name of the pointer, we have to put the keyword constant. We did the full practice at the end, right, everyone? Remember, we learned reading, pointer to constant pointer and blah blah at the end of package number 3. Okay, so make sure so now let me explain the answer here. So we said that we are creating a constant pointer. The first thing you do is that you put the keyword const, right, and you put it next to the pointer, the pointer label. So we have the pointer first. Which point to a pointer, right? which point to a pointer, uh, which point to pointer, sorry, and pointer is up here, and pointer up here is pointing to a pointee, right? So that means if you are pointing to a pointer that pointing to an integer, right? Then what you are pointing to? You are pointing to what? You are pointing to a integer pointer, right? Everyone's good here, right? So the type here is not an integer, but a pointer to an integer. That's how you break it down. Everyone's good, right? So this is a pointer itself. And then the pointer is pointing to an integer pointee, right? The integer in here, let me change the color. This is a pointee. Everyone's good? Yeah. And the easiest way to read this is this, as I gave you in package number 3, right? The easiest way to read this is go from right to left. Go to right to left. You said, I have a constant pointer, right? And then it point to a constant pointer that is point to a pointer, and it point to an integer. Are we all good? Right? Constant pointer, point to a pointer, point to an integer. Any questions here? Any question here? After package number 3, this is pretty straightforward. Yep. Okay. So online number 18. It's pretty quiet here. Are we okay with this, or any question, everyone? Sometimes quietness scare me. Yeah, I'm scared when I lose students. I want to make sure everybody understanding. Any question for me? Are we all good? Can I have about 5 confirmations before I move on to the next one? Yeah. Oh, okay. All right. So quiet. Sometimes it's mean it's easy for you. So please quote an L value reference to reference a what? To reference a what? Everyone? When we have a pointer in front of the pointer, means we are referencing what? We are referencing the pointee, right? We are referencing the pointee. Are we all good here? This is we call what? D what, everyone? The dereference operator. So if we need to create an L value, right? We need to put one ampersand, and we put the reference, and it's referencing the object, right? The pointee. So we put the reference in front of the pointer. Are we all good now? Everyone's good? Yeah. Okay. The next one, we said we need to create an R value reference to reference the pointee again, right? The pointee again. And we know the pointee is an L value. So we know what? So we're going to start writing. We say, I create an R value reference, and I want to reference a pointee. However, the pointee is an L value. So I have to make sure that I move it to make it an R value before I can reference it. Does it make sense now? Does it make sense now? So now if we have, all the references to the pointer, to the object, then we can, use, any method. But let's make sure we always answer the question. We can use the R value reference to change the value of the object. What does move do in the background? For a split second, move gonna switch, right? The mode of the data from L to R value. And that's what we learned in package number 5, right? Can we write it as integer reference move? No, it is correct in terms of thinking, Harry. But in this case, the question literally asks for an R value reference. Then we want to put the double ampersands. Does it make sense, Harry? Right? Are we all good? Yeah. So when we go to the interview, right? When you go interview, be careful. Are they asking for the result, or they are paying attention to the, our way of thinking, our logic, our mindset? And so when people want to see if you are someone who know how to teamwork, who know how to work with other people, they're going to look at the way that you problem solve, look at the way that you get to an answer. If they just care about your hard skill, whether you can produce something or not, they pay attention to your answer. So that's why oftentimes we go to an interview, we forget about one or two. That's why we go home and we say it's not fair. It's not a fair interview. It's it's weird. It doesn't make sense. But actually, there's always a logic. Okay. What's the difference between Harry's code and code online number 22? What's the difference between? We talk about this, right? We talk about this in package number 5, right? One is an old time one, right? If we say integer I equal to 5, that is the old time 2000. Sorry, today I keep saying 2000. That's weird. It's 210, right? Now we all good. But in the modern C++, we know that 5 is an R value, and if we want to reference an R value, it's in the modern time we do uh, integer R value I equal to 5. Are we all good now? Okay. Yeah, Alfonso, that's correct. So who has the question again? It's Jay. Did you get it, Jay? It's not the same. And the best way to explain that it's not the same is that if we go to an interview and they are trying to evaluate if we know modern C++ or not, and if they put a question saying, I want you to write an R value reference, and we insist in saying, this is your answer, right? This is the answer. What do you think you're going to get? Okay, so always just look at the job perspective here. You get kicked out. Okay, good. So Harry answer Harry's own question there. Make sure we have to answer the question asked. That's right, Edgar. It's kind of answering what the question is being asked, right? We may know a million of things, everybody. We may have a degree in psychology, but if we are interviewing for a computer science job, they are asking about computer science, they are asking why the chicken crossed the road, right? In computer science, we say because it needs to get to the other side. It needs to go from 0 to 1. That's it. Okay. We don't want to talk about all the 5 books of psychology explaining why the chicken crossed the road. So that's the whole answer here. I know we can look at things from different lenses, right? Okay, does it make sense? Did I answer all the questions here? Can we move on to the next one, everyone? I'm spending a lot of time explaining this. I want to make sure we finish the lecture as well. How are we doing? Can I have about several confirmation before we move to the next one, please? A6. Oh my God, my ears and nose are stuck. All right. So the next one, oh, this is an interesting one, right? So this is the same package. So package 3 and package 5, huh, everybody? Almost, huh? Right? Oh, package 5 and 3 and 5. Those are the two that we focus on. In this question, the focus is on line number 39 to line number 43, right? Let me walk you through this, okay, everyone? So 39, we have a vector, right? Okay. And 32, we have another vector, right? I know that our classmates have a lot of questions here, and a lot of question is good, but for some classmate who is trying to catch up, a lot of questions may confuse them, right? So I try to go, at different paces all the time to make everyone happy. Let me ask, how we doing? Can you give me a green dot if you're doing fine, everybody? I want to make sure that we are doing okay here. How we are doing here? Are we doing okay, everyone? Can you give me a green dot? Yeah. Reviewing okay. All right. Okay. So what happened on line number 39 is that we create a vector 1. On line number 40, we create a vector 2, right? Line number 41, what happens? Can somebody explain quickly? On line number 41, what happened? On line number 41, when we did a swap, what happened, everyone? What is the content of vector 1 at this point? And what is the content of vector 2 at this point? Vector 1 content. Can somebody give vector 1's content? What is vector 1's content right now? Vector 1 content now is what? 2, 4, 6, 8, and 10, right? Are we all good? This is our assignment 2, right? Assignment 2, that's where we learn all of this. And then we swap here, right? This is what from package number 3 as well. And package number 5. So are we all good? So do we all see the effect of line number 41? Yeah? All right. So now on line number 42, let's pay attention to this. On line number 42, we are saying I'm creating a pointer that, that pointer is pointing to what? Pointing to what vector elements ago? Vector 1, right? We have vector 1. And it is the first subindex, so it's the second element. So it's pointing to, pointer is pointing to 4, right? Are we all good now? Okay. Pointer is pointing to 4. So now on line number 43, right? We say y is equal to the dereference of pointer. What does it mean by pointer plus 2, everyone? Pointer plus 2 means what? Pointer plus 2 means what? We are moving the pointer by 2 memory units. Everyone's good here, right? 2 memory units, right? And each memory unit in this case is an integer, right? And each memory unit here, has, the next element. So if we move here, then we say 1 and 2, right? 1 and 2. So now we are moving the pointer to this point here, right? And y going to be the dereference of that, location. So y equal to 8. Does it make sense here, everybody? Y equal to 8. Are we all good? Are we all good? Yeah. So now we just plug it in. So if we have, pointer there and y equal to 8, right? Y equal to 8. So if y equal to 8 now, then what the value of y here, everybody? Y equal to what? Up here, y equal to what? Y equal to 8, right? And now here, y equal to what? Y equal to 9. That's right, Alfonso. And then when we see out, right? When we out and see out, x equal to what? Everybody? X from global, right? X equal to 1. And y equal to 9. Are we all good now? Right? And now here we increment y equal to 10. And then here we have x, right? X equal to x minus 1. So x equal to what? X equal to x minus 1. X equal to what? Everybody? X equal to what? X equal to x minus what? Negative 1 equal to x plus 1 equal to what? Equal to 2. Why are we so quiet, everyone? Come on, it's math. How come I don't see anybody texting? On line number 52, right? On line number 53, we got 1 and 9, okay? On line number 54, 54 we are calling T2, right? T2. When we call T2, what we got in T2, everybody? What we got here? So now we are declaring x as a pointer to the value of y, right? Okay. And if it's a pointer, and when we output on value, it's gonna be the address. Everybody here? The address of y. And what is the value of y in this case? We came from here, right? So y equal to 10. So here we go. On the exam, right? You can say that this is an address, right? And this is 10. So now if we call T3, what's up with T3? T3 now, y here is a local or global y, everybody? On line number 25. Is that a global or local y? It is a local, right? And x is currently value of 2, right? So now we have this local y equal to 2. And we have a static, this is a local x, right? Everybody's good now, right? So now if we output, right? If we output and we say x plus 1, that is equal to 3. Y plus x, right? Y plus x is equal to what? Is 2 plus 2, right? So it's equal to 4, okay? And then we say x, plus equal to y. X plus equal to y. So x plus equal to y and x equal to what? X equal to what, everybody? X equal to 4, right? 4. Okay. So now, why is it 4 important, everybody? Why is this 4 important? Because of what? Why do we care about this 4? Because it is a local and static variable. That means if we call it another time, right? What's gonna happen? What's gonna happen, everyone? It's gonna get increment, right? Are we all good? So now, if we call T3 again, right? If we call T3 again, let me put a 2 dot here. If we call T3 again, what happened? This y here is a local y, right? This y here is a local y. Okay, so it's still equal to 2. And then we have static x here because x already exists, so we're gonna skip, right? So we're gonna print out what? It's gonna print out what, everybody? It's gonna print out the value of x equal to 4, right? X gonna be equal to 4. And y gonna be still equal to, y gonna be equal to what? X equal to 4 or 5. Oh wait, it's gonna be equal to 5 here, right? Because it's already 4 here, everybody. So it's gonna be equal to 5. I don't feel good today. Equal to 5. And then where is it? I got so equal to 5. And then x plus y, right? So this is 4 plus 2. So equal to 6. Can you follow okay, everybody? Yeah? This is a second call. This is second call, right? So it's all because of this 4 here. Okay, so 4 plus 1. Let me give you detailed information here. 4 plus 1 equal to 5. And this is 4 plus, 2. So it equal to 6. Are we all good? Yeah? So now T4. T4, right? T4 locally, we have this one y is local plus equal to x plus 1. So it's equal to 3. And then we have, z is a reference to y, right? And then z, over here we have what? Z equal to what? Z minus 1, right? Equal to 3 minus 1 equal to 2, right? So now if we print out, right? X plus z means what? Means 2 plus 2, so it equal to 4. And then we print out the value of y. Y is currently 2, right? Okay, any questions here, everybody? Any questions? A lot of basic math, right? Are we still here? Are we still here? Are we still here? Yeah? Okay. A7. Let's go to A7. A7 the same, right? Kind of the same. Let me focus on the where we should have question here. Right here, right? Right here. Right here. We have an array, all right? 50. So what is the A3? What is the value of A3, everybody? Array 3, array sub 3. What is the value of array sub 3, please? So we have 0, 1, 2, and 3, right? So its value of 8. What is the size of the array? What is the size of the array here? What is the size of the array? What is the size of the array? It is equal to what? No, no, no. Size. Oh, I like it. Whenever there's some confusion, there's an opportunity to learn here. In the class, we learn size of, right? Right? And in 220 and 210, we learn length. So the difference here is number one, size of, right, is for the memory size. Are we all good? Okay. Size of is a memory size. That's what we learn in our package number 3. That's a different one. Size is almost like length. Okay, but size give more information in terms of memory when we work with data structure. That's the difference between size and length. And we don't have length, right? We don't have length. Remember, we learned that in our package, right? We don't have length. Okay. So now in the modern C++, everybody, earlier we did not have size either. In modern C++, I would say C++ 2011. That's when we start to have size. And the size here going to return 7, right? Everybody's good here? And 8 divided by 7. And what is the type of y again? Y is global, right? And y is an integer. Everybody, on line number 9, right? So if 8 divided by 7, right? And it is an integer, it's going to get the floor value. Oops. 8 divided by 7, you're going to get floor value. So y equal to 1. And that's it, right? Y equal to 1. And then we do all the swap as we did in class, okay? And then we continue down here, and this look kind of, crazy, but actually it's not much, right? You just have to dereference the pointer, right? And then subtract 1. Are we all good? Dereference the pointer, right? And minus 7. That's mean is plus 7. Are we all good here? So make sure we review our basic math, right? And we're gonna be fine. Okay. On the top here, so swap 1 is the swap by is pass by value. We learned in class. Pass by reference. See that? So the previous question really prepares us for this. This is pass by reference L value, right? This is passed by constant reference. That's it. And this is passed by the, passed by pointer, value of the pointer. And this one here, number 5, is equivalent to number 4 in our package number 5, right? We are passing a reference, to a pointer, right? Reference to the pointer. So if we review our package, and then that's all we have. And if you have more questions, please let me know. Okay, I want to make sure we finish this review today. Let's go to the last 2 questions. We have this one is just so when we talk about the example of IDO, right, what we focus on, everybody, is that the process, is that programming methodology, or is the result? And we watch the video together, right? So what did the IDO team do during the problem solving phase? So you want to go back to package number 3, right? In the problem, recognition, right? Problem formation, right? How we, gather all the information, how we identify all the variables, how we recognize and define a problem, right? That's what we've been learning in the last 2 assignments, right? And the last question, in the future, if you will be a CEO of a software company, will you fire people better than you? How you feel sitting with those people? Anybody decide to fire people who are better than you? Anyone? Anybody? Anybody decided to fire people that are better than you? No. Usually, a boss. So this is from working experience, everyone. If if somebody is insecure, they are afraid of working with people who better than them, and that boss will not last very long, right? Doesn't matter if he's running for a state-owned or private-owned company. Doesn't matter if it's in a public or in a communism or capitalism system. It doesn't matter. The insecure people cannot lead anyway, right? um, what we should learn from this is this: as we go out to work, everybody, right? Each of the people that we work with gonna have their own expertise, and we should be happy. We should be happy to work with people, who are, good at what they are doing, even if they are better than us. Learn from them, right? And being a leader doesn't mean that you have to be better than everybody in every aspect. Being a leader is somebody, right, who able to, collaborate people and make people sit together and work toward a common goal. That's what it is. And if you are a CEO and you are busy competing with each person in your organization, then you can't be the CEO, right? CEO is not there to compete with people. CEO is there to make people work with each other and bring the best out of them. Okay. And there's more if you want to read on our file manager. Okay, last time where did we stop? Oh my god, did we run out of time already? I always try to explain things thoroughly, and we may run out of time. But let me see. Package number 7. We finished on line numbers 2067. Package number 6. We are at line number 12. Can I have 5 minutes going over a little bit more for you, everybody? I don't want you to be behind other section too much. Can I have 5 minutes for package number 6? Yeah, is that okay? Right. I want to catch up with the material a little bit. So package number 6, yeah. Package number 6. Uh, last time, last time we were on the first page, and somebody today already asked me to explain the initializer list again. So package number 6, line number. Did we say line number 12? Line number 12. Okay. So here we go. Let me try a little bit here. So in this package, everyone, um, on line number 14, we have a student constructor that takes no argument, right? Thank you, Isaac. On line number 15, we have, let's pay very close attention to here, right? And I hope that, we are changing the topic a little bit, make you feel better here. So if we have a student constructor that takes one argument, you want to make sure that you take a note here, right? It is one argument, right? In the modern C++, we have the option saying explicit. And why and what does explicit mean, right? I will explain. I will keep this best, element until the end of the package for you, okay? Until the end of this page. So now here's the initializer list again. The idea of an initializer list, and the initializer list is the column right here, right? The idea is that we are able to create an object and in the using the least resources possible. So we are using only one step here. We are using one step because we are saying this: in order to initialize my variable, my property favorite muni, right? I'm going to take the value that you are passing in, okay? And then I'm going to take the value here. This is passed by value. And then I going to initialize the object. So I know what what property. So here we go. If we creating this object, right? In 220, the first thing that we call in the constructor is that we're going to call super. And super going to give us an object with default value. And the second is when we override that value, with the value we pass in. But with the initialized list, we don't need to take two steps. We take only one step before the body. We said, I'm going to use this value here that being passed to me, and I'm going to create the object that has that value. I'm done. Okay. So that's what initialize list about. On line number 16, what I did was that if I give you an example of initialize a list using only one parameter, right? I want to make sure to show you how to use initialize a list for multiple, multiple parameters. So this is the way we do it, right? We just line them up, the same way that we did for the first one and separate by a comma. On line number 19, right, and line number 22, um, on line number 19, on line number 23, and on line number 27. On line number 19, we are accessing a static variable, right? So on line number 38 is when we have the static variable. When we have a static variable, right, as we discussed on the last page, we make sure that we initialize it. And the rule of C++ is that static variable have to be initialized outside of the scope of the class. That's why we go to line number 44 in order to initialize the static variable, right? If it is a static variable, it's a class variable. If we want to access a class variable, make sure we use the name of the class, right? And the scope resolution operator, and then the property. We do not use this, right? Because this only for this object. And if it's a static, it means it's a class variable. So we use that, class name. So if we are creating a getter to access a static variable, make sure that it is a static getter as well. That's what on line number 19 is about. Okay. On line number 23 and 27, as I explained to you last time, if we are using a getter and we are not changing the value of the property, we put a keyword constant at the end, saying that I'm having this function, this behavior of the class, right, to access a property of this class, and I'm not going to change the value. I want to keep it constant. On line number 24 compared to line number 28, I'm reminding you about the syntax again, right? On line number 28, this is the preferred way. This is a preferred way, because if we know this is a pointer, then we just use the arrow operator. We don't need to, do two-step dereferencing and using the dot operator, right? So this is not prefer, right? Not prefer, okay, or not recommended. So we don't use this one. Next thing, on line number 31, we notice that we also have a getter. We also have a constant here. However, when we return the favorite color, we actually appending, if the favorite color currently is gold, we want to append purple to it, because SF state students' two favorite colors are gold and purple. So now the problem here is that we said that we're going to keep it constant, right? But we still want to change one of them. So in order to do that, we want to put a mutable in front. Okay. So what does a keyword mutable do to a property of a class? This is if when we say mutable, everyone, when we say constant, everybody, okay, we means that we can access but change none. We cannot change, none. If we have a mutable, we have a constant, right? And if one variable have mutable, right, have mutable, and mutable means you can change it. So in this case, this is what we are doing. We are saying that I'm not changing any of the variable of this class, but the one that has mutable, right? So this is a beauty of C++, right? It gives you very specific control on every property of the class. So if you are saying that I'm not going to change about, let's say if you are not going to change 100 variable, but you have a mutable for one, that way you still save a lot of memory. Everybody's good here. Instead of saying that, well, I take out the constant, so I'm gonna make C++ set aside, processing units for me to be ready to change any variable. So that's what mutable mean in this case, right? In C++, on line number 19, on line number 23, on line number 27, right? On line number 31. Even though we do not declare inline, but by default, all the functions declared within the class scope of a C++ class are inline by default. However, if we have a prototype, that means it's not implemented inside the scope of that function. When we declare it outside, on line number 46, we have to explicitly declare that it's inline. Everybody's good, right? The next thing on line number 50, I want to bring the discussion of R value to the next level. In the last package, when I pass an R value to a function, I pass it by R value reference, right? But for the syntax this time, we are just saying, well, it is a student, it is the STU, a reference, right? So we are passing it, and it looks like an L value reference, and it still work, right? For what reason? So we're gonna learn, the anonymous object this time, everybody. Okay. So next time I'm gonna go through, everything that I just explained again another time for you. I just wanna make you think before we start the class next time. So next time we're gonna resume at line number 55. Okay. All right. I'm sorry. I took more time today. Just want to go through the answer thoroughly with you, and also want to do some more with the package. Thank you very much. I will see you on Wednesday. Okay. Make sure that we take the we look at the survey that I post on File Manager. All right. Thank you. Thank you. Thank you so much. Take care now. All right. Thank you. I will see you on Wednesday. Thank you.